Hello and welcome to 5th grade lesson 7-1. We're on chapter 7. Only 2 chapters left in this whole school year, or whatever we call the school year now, at home school thing. We're dealing with multiplying mixed numbers today. Not only that, but we will be multiplying mixed numbers using what we call an area model. Here's the 3 things they want us to do today, starting right from the top. Use the rectangle to make an area model and label the sides. Find and list the partial products. Label the partial products in the area model. Add the partial products to find your answer. You may need to rename fractions with a common denominator. So I'm going to leave these to you guys. I'm going to swing over. I have 2 example problems I'll walk you through. My first example will very closely follow number 1, just with different numbers. So my exact example problem is 4 2/3 times 7. So we're going to use this little rectangle here and make ourselves what we call an area model. And I think that label might be in the way, so I may have to shift that around in a second. We're going to represent our problem on this rectangle. So we're always going to start, if we have a whole number, we're going to start with that whole number. We're going to plug them right along on the side here. Just go ahead and put a 7 down on the right hand side. And now what we're going to do, we're going to split this 4 2/3 up. It's a mixed number, but we're going to give the whole number and the fraction its own little zone. So if I were to estimate around here, I would say like 4 holes would probably take us to right about here. We're going to split our rectangle up. This will be our zone for 4 holes. And this is going to be our zone for the 2/3 portion. Hopefully that shows up on my video. Okay, it doesn't have to be exact. If you're saying, hey, wait a second, the 7 looks shorter than the 4. Okay, fine. The measurements aren't the most important thing here. The important thing is, do you have your model set up in a way that you can do this next step, which is to multiply for each zone. For instance, I see a 4 here and a 7 here. They meet right here in the middle. So can you answer 4 times 7? What is 4 times 7? It's like 4 touchdowns, assuming you hit the extra point. 4 times 7 is 28. All right, so the trickier part for some of us here may be 7 times 2/3. You're saying, wait a second, I can't do that in my head. And there's a few ways you can go about this. First, what they're basically telling us is we have 7 groups of 2/3. So if you wanted, you could literally like draw it out. 2/3, 2/3, and so on and so forth until you literally had 7 groups of 2/3, and you can find out how many thirds that would actually be total. You could also turn this into a multiplication problem. Just literally taking 7, turning him into an improper fraction, and you can always do that by putting a whole number over 1, because 7 over 1 is the same as 7 wholes. So if this helps you visualize and solve, 7 over 1 times 2/3. The beautiful thing about multiplying fractions, you don't have to change any denominators, nothing like that. You literally just multiply across. So 7 times 2 is 14. And what's 1 times 3? That's right, anything times 1 equals itself, 14/3. Now the only thing I'm going to require here, the answer is 14/3, but I would like you to reduce this as much as you could. So to reduce, I want you to ask yourselves, how many times can 3 go into 14 without going over? And you can go, okay, 3, 6, 9, 12, and if we did another one, that would put us up to 15, which is bigger than 14. So that looks like it'll hit 4 holes, 4 whole times, will get us to 12. And then how many pieces of a third would be left over? Well, to go from 12 to 14, that would be 2 left over. So truthfully, 7 times 2 thirds equals 14 thirds, which we can reduce to 4 and 2 thirds. So once you make your area model, you're going to solve for what's inside. We did 4 times 7 is 28. We just found out that 2 thirds times 7 equals 4 and 2 thirds. And the last thing you'll need to do, you're right in the home stretch, add these two numbers together. What is 28 plus 4 and 2 thirds? And our strategy for adding mixed numbers here is to add the whole number first, or whole numbers. And in this case, we have 28 plus 4, so that equals 32. And then plug in the fraction at the end. 32 and 2 thirds. Okay, so let's take a look here with number 1 on page 233 and see how we can apply the example problem to our page here. Sorry, I'm a little distracted. I'm looking over on the Everyday Mathematics page, and I was looking to double check my answer that we did for an example, but I'm feeling pretty confident about it. I think we nailed that. So let's take a look at 3 1/8 times 4. And I'm not going to do this whole problem for you, but I'm going to show you the parallel between what we did here and what we're going to do here. So you'll notice with our example, we put the whole number to the right-hand side. So let's do that for number 1. What's our whole number? 4. So you're going to put your 4 right here. And then let's look back at the example. What did we put along the top? We split our mixed number into 2 separate categories, the whole number part and the fraction part. So let's do that. Let's split our mixed number, 3 1/8. Let's put the 3 in this zone here, and then we'll make a new section for the 1/8 right here. Okay, so in this case, we now have a couple of different multiplication problems to solve. We have 4 times 3 and then 4 times 1/8. And remember, if you want to know a quick way to solve 4 times 1/8, you can, if you're not feeling your whole, if it's not making sense in your head, you could always just turn that 4 into a fraction and multiply across to get the answer for realsies. Okay, so you're going to end up with 2 answers that fit, one that fits in here for 4 times 1/8, another one that fits in here for 4 times 3. You're going to add those together to get your answer. Now, before I set you loose, I'm going to throw one more example problem at you because it's going to be a lot like what you see for number 3, which, if you're feeling good so far, number 3 is going to throw you for a loop. Here's my example. So we did a nice job with a whole number of times a fraction, but what if they do this to us? Which they will. I've already looked. It's there. What if they give you something like 1 3/4 times 2 and, oops, I want the whole number to be 2, times 2 1/3. Like, what a mess this looks like. 2 mixed numbers, both with denominators that don't match each other. What do we do for our area model? And the good news is this. They kind of help you out. Do you notice how our area models for 1 and 2 are one certain size? But did you notice what happens for number 3? I'm having a hard time squeezing down there. It's way bigger. It's because we're going to need an extra category for that other mixed number. So I'm going to make my area model here a little bit bigger to accommodate all the numbers we're going to have to include. So now, instead of a whole number over here, I have another mixed number. So that means we have to split him up too. Maybe put the 2 here, and we'll put the 1/3 down here. It doesn't really matter if you want to put this guy on the right side or on the top. It's interchangeable as long as you have them separated into their own category. So I'm going to make that a little bit darker because I know it's on the line. It's hard to see. And now what's our other mixed number? It is 1 3/4. So we're going to put the 1 over here, 3/4 right here. Divide them into their own sections again. And you're going to end up with what looks like a window pane. And we're going to do the same thing we did on number 1. It's just we'll have a few more partial product problems we'll need to solve for. So what I like to do is I like to seek out the whole numbers first, the multiplication problems that come easily to me. And I notice that I can do 1 times 2. This is where they meet. That's 2. And in fact, I know anything we multiply times 1 is going to be, it's going to stay the same. 2 times 1 is 2, which also means if I do 1/3 times 1, it's going to stay 1/3. So we already have half of our boxes completed. We're left with 2 times 3/4, and I sometimes need to go, I know 2 times 3 is 6, so that would be 6/4, which I want to reduce. So 6/4 equals 1 2/4, also known as 1 1/2. Okay. And now our last one we need to fill in for is 3/4 plus 1/3, and I'm going to go ahead and rewrite that down here so I can see it better. 3/4 times 1/3, you multiply across. 3 times 1 is 3, 4 times 3 is 12, so 1/3 times 3/4 is 3/12. Okay, I've got 3 minutes to finish this problem off. You're going to notice we have a situation here. We can still add, we need to add all these together, but we have different denominators. So 2 plus 1 is 3. I'm going to put that over here. Now we need to do 2/4 plus 1/3 plus 3/12. This is advanced. If you can do this, you're just about ready for middle school, I reckon. You can use strategy number 2 from chapter 5 before we left on break, where you can ask yourself, if we're going to add these, we need a common denominator. And strategy 2 was, can one of these fractions be a multiple of 12? Like, can 3 go into 12, basically, is what I'm asking. And it can. 3 times 4 is 12. So we can multiply the 3 and the 1 by 4, which would give us an equivalent fraction of 4/12. Am I still on the screen? Barely. Okay, and now we're going to ask, can 4 go into 12? It can, 3 times. So if we multiply him by 3, we'll get 12. But that also means we have to multiply the 2 times 3 as well. So 6/12. And now we have common denominators. And the denominator stays the same when we're adding. 6 plus 4 is 10, plus 3 is 13/12, which reduces to 1 and 1/12. Add the original whole number. Oh my gosh, this is crazy. I can't believe. Woo, this is going to be a lot. Plus 3. 1 plus 3 is 4, and a 12. That's your final answer. My goodness. If you're sitting there and your jaw just hit the floor because this was so much coming at you at one time, I can't blame you. So maybe what you want to practice is taking it as far as you can. So I have about 30 seconds left. For number 3, if you don't know how to find the final answer, at least practice creating the partial product zones and trying to multiply, at least doing this part here. And if you can't quite add together all the different numbers at the end, we can continue working on that in the future. Any questions, hit me up. Elsewise, I'll see you guys for lesson 7 too.